All right, folks, it's Bass Action back in action here. This is our last example of coordinate geometry, and in this one, we're going to look at the distance between two parallel lines. Similar to the conversation that I had at the beginning of the last video when we did the distance from a point to a line, if you are trying to find the distance between, let's say, two vertical lines, all I would want you to do is make a quick sketch and count between them. If you were trying to do the distance between two horizontal lines, all I would want you to do is a quick sketch and count between them. The steps that we're going to go through in this video are not necessary when the lines are vertical and horizontal. We only need to do them when their slopes are something else. Okay, now, also similar to that last video, when we want to measure distance, it has to be done on a perpendicular. So since these lines are not vertical or horizontal, I need to somehow find a way to measure a distance on a nice perpendicular. I cannot just count this distance, because even visually we can see that if we tried to just count the difference in these y-intercepts, we'd have a difference of 10, but clearly when we look at this, this is clearly smaller than 10 units. So we need another strategy, and that's what these steps are going to list. What we're going to do is we're going to get a line that is perpendicular so we can get an intersection just like we did in the last video and then calculate a distance. So step one says to write the equation of a line that's going to go through one of these y-intercepts. I've pre-graphed them for you again. It's going to go through one of these y-intercepts and be perpendicular to it. It doesn't matter which you choose, but I personally like to choose the one that has a positive y-intercept if I get to have that as a choice. So in this case, I'm going to choose the red line, and I can see from the equations, notice that I've color-coded them. The red equation here is the red line, and the blue equation here is my blue line. So I'm going to deal with the red one first, and I know then that the slope of my new line, my perpendicular slope, should be a negative 1/3, and I know its y-intercept is supposed to be the same as the y-intercept that I just did, so it should be a 0,4, which means I can jump straight to point slope form of a line and say y equals negative 1/3 x plus 4. So that's going to be the line that's going to go from here, and then we'll go down 1 and over 3. And I'm just going to kind of sketch that in so that we can kind of see it. It's a little harder to do on an iPad, but I'm pretty sure that you guys could do it nicely on your paper. So now I've made this nice perpendicular. Now what I want to do is I need to know this point of intersection right there. And the only way I can get that point of intersection is to solve the system of equations between the blue line and the new black line that I've created. So those are the two equations that I'm going to set equal to each other. So I'm going to take my blue line, my 3x minus 6, and I'm going to set that equal to the new equation I just did, negative 1/3 x plus a 4. And then just like before, I'm going to clear out these fractions. So I'm going to multiply everything through by 3. So I'm going to get a 9x minus an 18, a negative x plus a 12. I'm going to move my variables over to the left. So I'm going to have a 10x. I'm going to move the constants over to the right. So now I'm going to have a positive 30. So I get a nice x value of 3. Now I need to take this x value and substitute it back into one of these lines because I'm looking for this point, so it has to go into the blue or the black. It doesn't matter which. So when I sub that back in, I get a y equals, I'm going to choose the one without the fraction, so I'm going to have a 9 minus a 6, and that's going to be 3. So the point of intersection is the point 3, 3. And I need to find the distance from that point to the other y-intercept because this is what I'm now calculating. And that other y-intercept of that original red line was the point 0.04. So now, when I go to calculate that distance, it's pretty easy here. So I have a 3 minus a 0, which is 3. I'm going to square that in my head, and I'm going to say 9. Then I'm going to do 3 minus 4, which is a negative 1, and when I square that, it's going to give me a 1. So my final answer doesn't even require any simplifying in this case, it's just a square root of 10. So that's a distance between two parallel lines.